Testing.
It works. Very good. Does anyone feel like coming a bit closer to the front? Because I see... No? We might threaten you with lower case in the demo, so I'm not sure.
I will do all the presenting lying down, so you won't see me if you're not in the front. Okay?
No. But Magnus, we need to get ready because we have around 150 slides to go over in 40 minutes, so we better get started.
Yeah.
Or should we start with the demo instead?
Yeah.
Okay.
Yeah,
so
the hell with all the slides.
Instead of starting with 150 slides, we will start with a 10-15-minute demo on OpenShift and some of the cool things that you can do with it. And then we'll talk to you a little bit about the architecture behind it and some of the real-life use cases that we have done together.
Cool.
So, should we go ahead with the demo?
Yeah. Could we start off by just probing, not physically probing you, but mentally maybe? Like, who are like hands-on with the Kubernetes as it is now? Raise a hand. Yeah.
Not that many.
No. Knowledge of containers and Docker, CRI-O.
We have some there.
Okay, cool.
So we can start a bit slow and
yeah, we will.
give the demo. All right.
All right. Okay, so we're just improvising everything here now. So we'll see how it goes. This is OpenShift. This is a self-service PaaS for container technology. So, as it turns out, just having an orchestration system for containers is not enough. You need some other pieces as well, which I will now demonstrate. Excellent. I'm going to click here and call this Magnus Dev. By the way, can you see this? Is this large enough for you guys in the back?
If you cannot see, then you should maybe sit a bit closer to the front.
Yeah, come closer. Click. Oh my God, did you see that? Did you see that? What happened? How fast did it? It just like literally took a couple of seconds. Do you know what happened? No, okay, let me explain. So like I said, just orchestrating containers across a couple of servers, that is basically not enough. You need some other pieces in the puzzle as well. Now, actually, when I created the project, it's called a project in OpenShift, we created a brand new Kubernetes namespace. What we did more, because OpenShift uses a SDN technology called OpenVSwitch. So we created a brand new SDN. On top of that brand new SDN, which implements VXLAN. So if you like VLAN, do you like VLANs in your companies? Probably, yes. So there's a software version of it called VXLAN, and on top of that we put an IP network. So ask yourself, how long does it take for you to get a new segmented network and an IP network on top of that? It's like 3 weeks, 10 weeks. It's impossible, etc. Okay, so that's why I was so like, whoa, that was cool. Okay, still we haven't actually done anything. So I'll try and show you how to do some cool stuff. So there are a number of ways that you can deploy containers on top of OpenShift. You can select from the service catalog, which you configure by yourself, or take stuff which is already populated with, or just point at containers located anywhere that you have access to and deploy from there. So, but in this case, I will just select a simple application. In this case, I will just take this simple PHP application, and I will select PHP 7 to deploy on. I'll call this app PHP 7, and I will just grab some simple PHP code on GitHub that I wrote for this, and just click OK. It was simple enough. Can you do that, like 3-step click process? Then you can deploy containers on top of OpenShift. So what I'm now doing is that this is using a source-to-image system which pulls the code from version control, builds a container for me, and deploys it in my segmented space here, and safety of my project. So if this is compromising the whole company, that is still a bit okay. Okay, so we will do something which is common. Now we have an application. Should I show it maybe? So here's the app. It's quite simple app. Just says this, okay? Cool, so that works. So I'm gonna deploy the same code, but on a new version of the PHP framework. This is gonna be real complicated. 7.0, that is cool. I'll call that PHP 7.1 and create. Okay, close. Root. Okay, so now I am deploying the same code on a new version of PHP. So this would be a normal thing. We're just doing some basic lifecycle management. I'm gonna show you how easy it is to do some zero downtime deployment techniques. Number 1, the canary deployment. Are you familiar with it? Raise a hand. Okay, right. So so we're picking out basically some user. It is you in the red T-shirt there, and he is a domain specialist in our stuff. So we're gonna allow him to test this out, so we see if everything blows up or not. As you can see, each version of our application has its separate communication endpoint. So that's quite useful. So we can, so if I just click here, you'll see the version running on PHP 7.1, and this was PHP 7.0. Okay, good enough. So that's quite easy to do. Then you can do a canary deployment. But what if we like to do something more fancy, like blue-green, for example? So I go into this place where I can configure something called a route. This is configuring the entry point into OpenShift. So I will just call this PHP blue-green. Service here, this is what I'm pointing at. This is the PHP 7.0 deployment. Okay, create. Okay, that was it. If I just do like this, hang on, and see, can you guys see this? And do some clever, well, to sleep for a second, do a curl to this URL, grep this stuff out. Did you see what problem did I do? Okay, here we go. All right, so I'm just calling the endpoint and we're getting some response back. Fine. Okay, so currently it's pointing at the 7.0 version of this. Just go into the route, and I'm clicking now because it's a bit more visual for you guys, and select 7.1 instead. Just save this. Oh my God, did you see how fast it saved? I'm just trying to make a joke now. Okay, go back here, and we can see that we have done a blue-green switch. Oh my God, José, this code is crap. The whole company is burning now because I didn't do proper CI/CD. Okay, let's go back, switch the service back to the previous version, save the route. That was complicated. No. So this is typically rocket science at a company, because then you need to have some automated integration to the load balancing systems that you have, and the load balancing team, they're like this. What automation? I have my NetScalers here, and I have been clicking in interfaces for 20 years. Don't tell me how to do things. Please submit a ticket in ServiceNow and wait for 3 weeks. That is how it is. I mean, I see literally hundreds of companies all over Europe. This is how it works. Okay, so cool. That was a green-blue deployment, and I just did it in a couple of clicks. Let's do an A/B. You know A/B deployments? Raise a hand. Few. Okay. PHP A/B route. So A/B deployment is that we know I mean, it was me that wrote the code, so there's a high probability that this code is absolute shit. So we're gonna take it easy when we deploy. We're just gonna take a small percentage of the traffic and send that to the new version. So the only thing that I do here is just check this simple little box. Split traffic across multiple services. And now I say, let's have 25% of the traffic going to the new version. Click create. Okay, that was fast. No tickets. Where's the? Okay, so and then we will just change this little route, so we instead go about and communicate to our entry point, which is has some load balancing. So every fifth call is now going to the every fourth call, I mean, is going to the new version. So that's good. Okay, but and now that seems to be working fairly fine. So we'll adjust this, and let's have 50% of the traffic instead. Say. Hello. Okay, 50% of the traffic is now heading to the new version. Okay, so I think we are ready for a proper move. So I think we should scale out the new version here so it can take a bit more load. Blah, 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 blah. Oh. Okay, now we have 5 containers serving this workload. So that was fairly simple. So we can see this load balancing as well. So see it more in detail. That it can do. There we go. So, no wait, sorry, I copy-pasted wrong. No.
I think it's the right one.
Yeah, no, I didn't use the correct route. Routes.
But you could see the different IPs there as well.
Yeah, I took this one. Yeah, no, but I wanted to see 5 different versions in a row because, yeah, there we go. So you can see how it's load balancing across. Okay, cool. And so this scaling is something that you can tie to arbitrary metrics. So we have a cloud company in Holland. They have this novel way of doing cloud. They put computers in people's houses. And they exchange so for them to put a 18-inch rack in your basement or something, you get free heating. So they connect, the metric is temperature in your house. And if it's low, they will route more cloud workloads into your house. So you can totally do that.
And Magnus, should we maybe
we
go
can
over and talk a little bit about the architecture?
Yeah, absolutely. So this is that was like Canary, AB, and green-blue, like super simple, and that is basically it. Okay, so you can switch the screens to the.
And you have the remote. It's the green one.
Oh, I just push here.
Get the screens. There we go.
Oh. Okay, and then I just click on. Click.
There you go.
Oh. Powerful. All right, so first step of the make a point of is the fact that you can put OpenShift on top of anything you like. So, Red Hat is an open source company. We like to be able to opt for different things, select. So run it on bare metal servers, run it on any virtual infrastructure you like, or different public clouds, etc. Have a cluster which is mixed and is running partly on different compute platforms, So that's perfectly fine. Then you have nodes. Then, the concept of nodes in OpenShift. And they run containers. It's quite simple. Repeat with me. Nodes runs containers. Runs containers. Yes, okay, you're getting this. Right. Secondly, a container is referred to as many different things. Container image when it's at rest, a container, just talking about in general, and a pod. That is a Kubernetes concept, which is the atomic unit, the smallest thing that you can manage, which is typically one container, but could be more, but let's not go into that. So pods or containers, they're orchestrated across the different nodes. You're with me so far? Nod, so yes? Yeah, good. So then you have something called a master. The masters are the rulers, the keepers of the cluster. They worry about, they're like your parents, but if you're a cluster. So anyways, the control plane, and they have some different tasks here. So first up, for example, API and authentication. So everything goes via REST. If it's CLI or GUI, etc., everything is fed through this one point, which is the API. Everything is authenticated. There is no anonymous API calls. Good. Secondly, data store. So this is at CD, if you're familiar. So it's a key value store, and inside of this key value store, you have the current state of the cluster and the desired state of the cluster. And the master is always looking at what's the current state, what should the desired state be, and when you saw me scaling up to like 5 pods, that is what happens. It's like the master says, oh, desired state is 5, but there's only 1. Let's make it 5, okay? And it happens fairly quickly. Then we have the scheduler. So the scheduler is the one that pulls containers out of a registry and deploys it onto the nodes. So, and scheduling in Kubernetes is a fairly simple thing. So because this is a technology which scales into the billions of things, it needs to be quite simple for it to work. So it uses a concept of labels. So a container has a label, beer. Node has a label, beer. Container beer ends up on node beer. But this is a quite flexible concept, and it's just basically your imagination that stops you. Have specific labels for different security zones, availability, physical locations, where are you in a development process, just apply labels. Okay, so and then the schedule then orchestrates the containers across these different nodes. And you can do smart stuff like anti-affinity ruling, like, oh, by the way, this and this should never be on the same node, or they must be on the same node, and so on. And also, naturally, we keep state on what's the saturation of a node, so maybe it's not possible to schedule something, and then we don't. Okay, so you create these policies as you wish. Then, when you have containers, as you saw, I was just scaling out. Now there are 5 containers of my app. Now there's 1. In the IP world, that would be, in a traditional IP world, that would be problematic. Because everything that gets on to the IP network needs to have an address in order to communicate. And so because containers are not there to stay always, then we need a layer which is a bit more permanent, the service layer. So this is, in OpenShift, is owned by load balancing functionality in the cluster. So everything you deploy in OpenShift goes via load balancers. Well, you can bypass them, but it's not done out of the box. Anyways, so that is all cool, and that means that people can discover each other as well. If you're a container without a state and you pop up, hello, whoa, where am I? Where's Jose? I ask the service layer, and it just directs me to him, so we can have a conversation. Good. Health and scaling. So, yeah, you saw the scaling in Works. I've explained how it works. You understand it fully. You're professionals now. Congratulations. But health is basically what if something goes wrong. Then the masters detects this. It's used by, so we have two sorts of health probes. One which is basically, did the process start up? Do we have the port yet or not? And secondly is to do an actual test, like do the app like respond with 200 when we probe it on this API point, which means that it has a connection to a database somewhere else in the world or something. And well, if something is sick in the container world, it gets shot. There's no like, oh, let me make you feel better. It's a and then you get a new one. It's a harsh world. Okay, so the master remediates any failures. Then you have the router layer, which I showed you, right? And that was super easy, and that's how you control communication from the outside into the actual cluster, and you have various ways of accessing OpenShift. I showed you a GUI. There's a CLI. If you like to implement a REST interface yourself, you can do that totally. So these are some few proof of concept architectures. So this is, for example, a POC architecture. One master, one node that has load balancers and stuff, and two nodes. Then HA for applications, just add two nodes that runs load balancers and add a number of app nodes. And then full HA, which is that you have multiple masters, 3 of them. You could have 5, don't have 5, have 3, because of etcd, how it works. Okay, and then you just add infinite number, just scale out until you're tired and don't want to scale out anymore. So that's quite neat. And then you see there where it says enterprise load balancer, that is like a global load balancer. At that point, you have to go to the load balancing department and ask them to do stuff. But that's okay, because it won't happen really often. Roadmap. So yes, let's talk about all these details until you fall asleep. No. So if you're not familiar, Kubernetes is a violent project. It's like, yeah, if I would have this presentation, but instead I would just run around the room and slap you on random. That is Kubernetes. It just moves super fast. But this is the roadmap. These are the important key features that you should like, oh, cool. And I will pick out some favorites of mine for you. Okay. Windows server containers. That is kind of cool. We worked with Microsoft for a couple of years now to get Kubernetes working on Windows. So you'll have mixed clusters with Linux and Windows, because there are some Windows native applications which will not be Linux. What more? The HBA custom metric, it's out now. FISMA moderate, do you have PCI DSS and all sorts of security requirements on you? There's best practice architectures for that now. In 4.0, which is in December timeframe around, Creo will be default. This is so big. You don't know what it is. But it is. So instead of having a daemon when Docker designed, what they called containers then, they had some issues regarding orchestration and etc. Because of that, they invented a daemon that you had to talk to the container. This sucks. when you have Kubernetes, because then you don't need that. So many moons ago, we created in Kubernetes something called the CRI, Container Runtime Interface, because in Kubernetes we were really tired of Docker breaking compatibilities, and also we saw that there's gonna be a lot of zip file formats which will need to be supported. There will be Rocket, there will be Docker, there will be Kata containers and whatnot. There will be a lot of different zip file formats. So that is how we do in Kubernetes to support everything. I have a default interface, and then CRI-O is a religious implementation of the CRI as a container, without any daemons, more high security, faster, so on. Keep on using Docker containers on your laptops when you build stuff, but when it's running in a cluster, that doesn't have to be Docker anymore. So that's quite good. Istio, have you heard of Istio? Like application developers doing microservices and all sorts of things. Okay, Istio is GA in March next year. That's a big thing. Serverless goes in tech preview, also big. There's a lot of serverless initiatives in Kubernetes. That was all, I think. And with that said, José?
Yes, thank you. So now, and thank you for both the demo and the architectural overview. And I think if you have any questions on it, I think we will still be around a little bit after by the booth. So actually, I will. You won't.
I will panic. I will run to a taxi, go to the airport.
But I'll give you his phone number if
yes.
So it's okay. Okay, so to talk a little bit about some of the use cases where Magnus and I worked together, I wanted to give 3 different type of work that we have been doing. So one of them being more of a project implementation, kind of long-running project. Then we have another example of kind of actually some more internal activity that we have been doing, and then another with a client, but also kind of just a one evening, one afternoon event. The first one that I want to share with you is something very dear to my heart. It's a project that I've been involved with for the last 2 years, actually 3 now, where we have a core banking application that we are implementing at a bank. And what you see here is what I will call the production line. So the default, the initial setup of the application was in virtual servers with the dev, test, pre-production, production. But then what we were seeing when we started the project and in the first months and in the first year, we saw that there was a big requirement for a lot of environments that the teams could use just for small tests, for some small POCs, for try out different things.
Just so I understand correctly, but you said core banking, and then we're talking about containers.
We will get there. Oh, that's. Have you seen my next slide? Because it's actually in the next slide. So, what we were seeing here was that we had this big demand for the teams to be able to try out new things, and it was very expensive in this setup because it would take a long time to provision a new environment. And if you have to wait 2-3 weeks to have an environment provision just to try something out for a week, then it's not a very use case there. So what we did at the time is like, wait, why don't we actually migrate this application into containers and see what we can get out of that? So this is actually what you can see here on the red side, where what we did is that for our development and test environments, we've actually migrated the core banking application into containers, and that's what we're running here for dev and test. And I will tell you a little bit about the actual content of a project and what the containers have. But the main thing to show here is that we actually are taking a lot of value out of having migrated to OpenShift in the development and test environments. So it is true that the production line is still a virtual server, but we do have all this flexibility on the lower environments for creating environments really fast, and I will tell you what was the change there, and for also destroying them. So it's not so much, oh, let's create this environment and then we need to maintain it and have it running and who's using it. It's more, oh, a team needs an environment. Okay, let's create it. Then they own the environment. There's a lot of self-service involved as well. And then they can experiment, and then once they are done, we just delete it and then can create some more. So, you asked about core banking. Yes, it is in containers. And to show you a little bit about what is actually the content of the core banking project and the containers there. So this would be, we have kind of one environment per OpenShift project. And what we did is that we took the applications that are running in the virtual servers and we migrated and containerizing them. So you can see here that we have a WebLogic container, an Oracle database container that is persisting the data, and then also an Oracle Service Bus containerized.
So
one thing you might be thinking, maybe that's what you're going to ask.
Yes.
These are, it's true, these are quite heavy containers. So the main driver to have these technology stack in the containers is that we do want to have the technology stack in our dev and test environments as close as possible to the production line. So we do have the containerized environment to allow us to have a faster provisioning and more control over the environments, but we still want them to be as close as possible to production, because maybe there's a different technology stack that would allow for better performance in OpenShift, but then we would run the risk of being too far away in terms of configuration to the production line. So maybe the test results wouldn't be as reliable. And if you want to hear a bit more about it, I will be around after, so you're welcome to catch me and talk a bit more.
But I just have to say, when I first saw the stuff that you were doing, I was thinking, you are insane. But then I did realize that what you did was reduce weeks to minutes.
Now you're stealing my next slide.
Oh, shit.
Which is this one. So maybe it is a little bit counterintuitive when you talk about migration and cloud environments that we are only having it in dev and test. But for us, we already have a lot of good stuff coming out of that and really enabling the teams to experiment and have results faster has really brought us a lot of benefit. So environment provisioning, as I mentioned, this was one of the big ones. We went from around 2-3 weeks. That's roughly how long it would take to get an environment set up in the production line, the virtual server setup. We did that to now under an hour. So we do have, the setup is containerized. For example, we have the database that I mentioned, it's an Oracle database, but we have kind of a baseline database that we have taken a snapshot of, so it's much easier to just create a new environment. We just load that snapshot and the database is up and running in 5 minutes, and then we have the application starting. So we got really, really big benefits here. And the other thing that is, I think it's quite amazing, that in terms of the configuration and the deployment complexity, because in the production line, there are actually a lot of components, and also means different teams handling the different components. Not everything is configured as code. So we actually went from that to a setup where we do have infrastructure as code. So all our Oracle DB setup, all the WebLogic and application setup, that's in source code. So it's much easier to, of course, then replicate, but also to have a more control on what changes are actually done, not only in WebLogic, but also in the database, and we have a better view of the application as a whole. So this was really, I think, for me, a very successful story of how to use and how to leverage OpenShift and kind of migrating to containers, and perhaps a story that is not the, I would say, the usual container migration, but it's just say that there's different approach, different ways of looking into it. So the second example was more on something that we have been running on internally at Accenture. So we do have this OpenShift internal cluster that we have running on Azure, and we have been using it across the Nordics to really learn and experiment with OpenShift and their tools. And there's also a lot of partners that have very interesting tools working together with OpenShift, in OpenShift. And we have been using this cluster to try things out. So we actually have been doing a lot of hackathons internally, where we reach out to different partners, and then we will have a hackathon where we say, okay, today we will install this specific application monitoring tool, and let's see how that works with OpenShift, how it behaves, what are the kind of information, what is the kind of information that we can get out of the tool. We have done quite a few of those, both on the application monitoring side, but also on the security side. So I think there's two areas where there's a very good ecosystem of tools working with Docker, Kubernetes, and OpenShift. So it has been really a lot of fun to do these different hackathons. We do tend to find some budgets for some pizzas as well, so that's always good. And the other thing is that it also allowed us to do some fast prototyping for some of the clients. So I remember one case very well, that we were at a client and we were discussing some setup with, it was actually with Bamboo at the time, and how could we set up Bamboo agents in the best way, if we could have them running in containers. And instead of kind of waiting for the team at the client to try it out, like, why don't we have the cluster up and running, let's try it out in the cluster. And then we actually ended up doing that in one afternoon, and then we were able to show the clients that this is how it would work and what you can do with it. So it was really, I think it's really fruitful to have that. And this kind of segues into the third example, where we kind of took those lessons. Okay, this kind of hackathon, it's actually quite useful, and you do learn. I guess it's both things. You do have some fun, at least for the geek ones around, but you also learn quite a bit about the tool and what you can do with it. So we took kind of this approach, and we got together with Microsoft, because we're also doing it on Azure. And in one evening, we actually went to one of our clients, and we say, okay, why don't we set up OpenShift on Azure and see what you can do and what it would bring you. So this was, again, there were pizzas involved. We got there. I think maybe the first hour or two was actually to figure out all the steps that had to be done and how we could do it with the client setup. And then we pressed a button or a couple of buttons, and then I think it was 1 hour of waiting, both for the pizza and for the cluster to be up.
Yeah.
And then we had the OpenShift up and running, and we could show the client what is it that you can use with OpenShift. So I think that was quite fun. Was it? What do you think?
That was cool. So I mean, we used one of the reference architectures to deploy OpenShift on. Well, you have all the different clouds, and just take one and use it and deploy it. It's not really rocket science.
No, and I think that's the very good thing with technology these days, that it's the cost of entry is so low that it's so cheap to experiment, and that's really what we were doing here, and I think it was very good. All right, and that was the kind of the three examples. So you got the demo, and I think they were professionals at what was it? Is it OpenShift architecture now? That you will get a certificate on the way out?
Yes.
Then a little bit about some more about the architecture and some real life use cases. So we hope you enjoyed it. I will stay around. Magnus needs to run, but I have his number, so we can probably figure something out if you have any particular questions. And see you around. Thank you for joining us here.
Yeah, I'll stick around for 1 minute 30 seconds if you have some quick questions here by the.